Hi there, and welcome to a lecture on recursion, which is really just functions calling themselves. Now, I want to be really clear about this. We're going to get a clear understanding of recursion because it's normally considered like one of the scariest parts of programming, but it really isn't, okay? You have a good foundation. We've gone through how functions work and how the call stack works and how functions transfer top to bottom control back to another line. As long as you understand those two things, that when you call a function, the transfer of control, the next line executed is the first line of a function, as well as the fact that there's a call stack there that contains the variables for the parameters and the local variables. As long as you understand that, recursion is not a scary thing. We just need to know why to use it and how it works. Normally, there's a slide in here that actually describes the problem of the thing we're trying to solve, and then we look at the Python way to actually solve it. In this case, there is no problem. Recursion is just another way of like looping, but without using loops. We don't use while and we don't use for. We use function calls to do it. The reason why we do this and the reason why we study it is because there are programming languages out there that actually don't use loops. They don't even have loops in their like language. There's no loops. And so what they have to do, they have to use recursion. And because recursion was invented like back in the 1950s with some of the original programming languages like Lisp, because they have this idea in it, it affected all of the computer programmers ever since then. And so now it's like this secret language, this like coming of age ritual that if you can use recursion, you're a good programmer. And if you can't, then you're a bad programmer. So that's why we're going to study recursion. And I want you to be you have to understand, if you don't get it the first time, that's fine. Sit down and play with it. Recursion, like I said, you've got, unless you're going to go out on a job interview tomorrow, you probably don't have to worry about it. So you have some time to learn about it. There's a really good book from No Starch Press. It's called The Recursive Book of Recursion. That's a really fun book to read to learn about how recursion works, like in all of the details. So again, in general, you can make looping code that looks like it loops without using the while or for loop, using a function which calls itself. And that's all that recursion is a function that calls itself to solve a problem. So let's take a look and see how we can turn these loops into recursion, into a function that calls itself without like while and without for. All right, let's take a look at the code here on the left-hand side. We've got a function named getName, and what it starts off with is name with an empty string, and then while the length of that name is 0. So it's going to, that while loop is just going to keep going while name is empty. It's going to get somebody's name, it's going to strip off the white space, and then it's going to check it again. And it's going to be like, hey, is the length 0? If it is, then it's going to prompt you for the name again, and then strip off the white space, and then come back up here and check for this. And as long as it's 0, the while loop is going to loop and loop and loop and loop. Once somebody enters something that's not just white space, the loop stops working, the loop stops flipping around, and we actually return that name. And so when we call player equals get name, we're sort of guaranteed that whatever string gets returned, when the name gets returned and put back into here, it's going to be a non-empty string. Okay, so that's the while loop version. Now let's take a look at the recursive version over here. This is the recursive version over here. So the recursive version, if you can see, doesn't have a while loop, but it does the same thing. So we're going to step through this one line at a time. When we get to this first line here, it says, give me your name, okay? And once you get the name, it strips it off. And then if the length of that name is greater than 0, it returns the name. Perfect. So it just returns it. It just returns the name, and that's what we would get back. But if the length of name is equal to 0, the next line says return get name. So at this point, the control of the function goes back up here and it starts all over again without a loop because we're calling the function again. But what happens is that we enter a new call thing on our call stack. So we start off at the module level. We call get name. That adds something to our call stack. So now we have a get name on here, and somebody enters like an empty string. It gets down here to return get name. The control goes back up here, and we get another entry on our stack, get name. And so it's going to try its thing, and it's going to get down here. And if we enter crap, it's going to call get name again. And so it's going to add another entry onto our call stack, get name, like this. And it's just going to be building up until somebody says, oh, I'm going to actually enter my name. And when they do, all of those values, once it returns this name, it's going to like come back and come out this return and into player. I know that's kind of hard to visualize. So why don't we just look at some running code to see how it works? So here's my code, that code that we just looked at with getting a name, but this is the recursive version of it. Let's go ahead and put a breakpoint right here and see what happens. Okay, so we're going to run this under our debugger, Python debugger. It's going to start up. Here's our terminal. So we're pausing right here, player get name. And if we look at the call stack right now, we're at that module level. All it's done is created a get name variable right here for this function and stored all of this code inside. So all of this code here is now stored inside this variable as a function. And we're here on this line, player equals get name. So let's go ahead and step in, okay? We're going to step into our code. And now we're here on that first line. Remember, this is the important thing about functions. When we invoke a function, control is transferred up to the first line of the function. So now we're up here. And we have to go through this function and return a value before we get back down here and assign it to player. So right now, it's waiting. Right now, this is just like, I don't know this part yet. I'm inside get name. So let's go ahead and boop this, boop. So now it's asking me for my name, and I'm just going to enter empty string. So now I'll do name.strip if the length of the name is greater than 0. Well, right now, you can see over here, name is equal to the empty string. So this is not going to be true. Okay, this is not true at all. So it's going to skip over that and return get name. So now I'm going to step into that, and now I'm back up here at the top again. So like I said earlier, recursion is like a loop, but we're not using while or for. What we're using is this call stack. Now you can see we're 2 steps in. We called module called get name right here, and then this get name got called here. Okay, so now we're inside get name again. And if I step over this and I enter space, 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 and I hit enter, now name is 3 spaces long, but once I strip it, now name is an empty string. If the length of name is greater than 0, not true, skip over that. And now we're on this line, and it's going to call get name again. It calls get name before the return. It has to get a value first before it can return one. So I can step in here and watch this call stack down here when I step in. Okay, currently I'm in this call stack of get name. I'm going to step into it. Now look, I'm inside yet another get name. I looped back. It essentially, this call right here transferred control back up to the first line. The only difference is that we're in a different call stack here. If we look through each of those call stacks there, we're going to see here, let's watch these local variables. Here on this get name, I have an empty name because that was the first time that I entered it right here. And then on this one here, I have another empty name because that's what I entered here. And on this one, I don't have a name variable yet because it hasn't run yet. I'm 3 stacks deep. It's like a dishes. These are like dishes that you stack on top of each other, and you're just going to keep stacking them until the plate isn't empty anymore. Okay? And that's what's happening here. So now I'm going to step over this again. I'm going to enter my name. I'm actually going to enter it this time. Here I am, Curtis. Okay? So I hit enter, and now name is Curtis. And when I step here, Is the length greater than 0? The answer is going to be yes. So now I'm just returning the name. I'm not returning get name anymore. Now what's going to happen here? Because we're on this stack, or on this entry in the stack. Remember what happens when we return a value from a function. This entry on the stack is going to go away, and this will get stored in a temporary local variable down here in the next stack down, okay, in the thing that called it. So we're going to take this name Curtis, and it's going to be transferred from this entry in the call stack to the one that called it. Okay, so let's watch how that happens here. I'm going to step next. Now we're back here. You can see, look down here at the call stack. It's like, why did it go to the next line here? It didn't really go to the next line. What happened was we returned the name, and this is where we were previously. And you can see right here, here's that temporary variable that came from the previous call stack, okay? So now we're on the second version of getName, the second time right here. So we just got rid of the first time, or Curtis just returned. Now we're on this version. This name right here is this one. And this name right here was the first one, which is down here even lower in the stack. Remember, the stack grows higher as we call more functions. So in this case here, we're going to return getName. Now, when I hit next, watch down here in the call stack, okay? Because currently I'm on this line in this version of the call stack. On the call stack further down, I'm also on this line. So I'm going to hit next. And what you'll see is this yellow line where I currently am, that's not going to change. But this entry here in the call stack, that's going to disappear. So watch this call stack down here. I'm about to click it. You can see that call stack is now, it disappeared. The one that we were just on disappeared. But I'm still on this same line because in this version of the call stack, that's where I was. And so finally I do it one more time, and now it's transferred that back down to here. And now I'm going to be able to assign that to the player, to that player variable. And if I had more things here, it would actually do something like a print statement. But that's how the call stack works to pretend that we have a loop here. What we're doing is every time we get to this line here, return getName, because this one got skipped, and so we didn't return that. Every time we get to this getName, it's like it loops back up to here, but what we're really doing is adding another entry to the call stack. And if it gets down here again, it transfers control to here, but it's like it's looping. But what we've done is we're inside a copy of it. We're inside another copy of that function. And now it's another version on that call stack. And if we get down here again and it's not there, it'll loop back. And now we're at the top of the function, but it's a brand new copy of that function. And so the function is going to execute, and once it's done, once it's like, hey, I've got a value, it'll send that value back to the previous copy, it'll do its thing, and then return its value back to the previous copy, and it'll do its thing. So it's like looping, but without whiles. So in general, the way that we turn a while into a recursive thing is we look and see what the looping condition is. That's the important thing, okay? And then we find out what's the value being tested right here. So the name, that's the value that we're testing. So this will become the first line of our recursive function. And then instead of having this condition, we do the opposite condition, the condition that's the opposite of that one. So instead of looping while the name is 0, we say if the length of the name is greater than 0, then we're just going to return that name. And then after that, we return a call to our function. Okay, so that's how we turn a while loop into a recursive function. I'm going to go back so that we can look at this code again, and I'm going to go ahead and highlight these things. So here's our function name right there. Up next, what we do is we say, what's the value being tested? So we start off with 0, a length of 0, and this is the value being tested. So that becomes the first line of our function. Then in the next line, we're like, what do we do with that value? Do we have to do any processing on it? In this case, we're getting rid of white space. So we're doing the white space thing. So you can see the stuff that was inside the for loop or the while loop become the first lines of our recursive function. Then what we do is we look and we say, hey, what is the thing that breaks? What's the thing that stops our loop? We do the opposite of that with our if and return the good value. That's what we're doing. We're returning the good value here. So that's this returning the good value. If we don't have a good value, that last line becomes another call to the same function. This becomes a call to the same function, which when we call the same function, again, it's like we're introducing a loop. Just like we had with while loop, it would come back up here. The recursive version loops the entire function, but without the while loop. So that's how they work out together. That's how we can turn a while loop into a recursive function. Now let's take a look at how we turn for loops into a recursive function. Over here on the left-hand side, we have a function that's going to add up all the numbers in a list. So we start off with a total of 0. And remember how our for list works. It's going to take each element in our list and assign it to the variable one at a time. And this function, what it does is it takes that element, adds it to the total, and puts it into the total. Once the for loop is done and we've exhausted the list, we return the total. This is very straightforward, I hope. I hope this makes total sense to you. Because for a lot of people, the recursion side totally blows their mind. So let's take a look and see what happens here. So the first line of it says, if the length of the list is equal to 0, if that value is 0, then we're going to return 0. And this is called our terminal condition. It's the condition that just stops it. There's no recursive call anymore. And that terminal condition is the same as our starting condition over here. So the starting condition and the terminal condition are the same. Then what we do, and in these for loops for recursion, what we end up doing almost always is we split the list somehow. And in this case, what we're going to do is we're going to split the list into the first value, the value at the 0 index, and then the rest of the list. Look at that. That's a slice. It's got that colon there. So it's going to start at the second value, the one that has index 1, and assign that as a list to this tail variable. So the head is a number and the tail is a list of numbers. And so then we return that number that was in head plus the sum of the rest of the values. And that's the really important part, is almost all recursion that has to do with lists, we take the first value off of the list, do something with it, and then add it or multiply it or combine it in some way with the rest of the list being passed to the same function, being passed to itself. That's how recursive for loops work. And so what happens here is when we pass in this 2-item list on the first round, it comes in as a 2-item list, then we split it into a number and a 1-item list, and then we take that number and we add it to the sum of the rest of the stuff, whatever's in that 1-item list. It's probably best if we just look at the call stack, because that's what we do, okay? Whenever we have a question about code, we should just write some code and run it and see what happens here. I'm going to go ahead and set a breakpoint right here. And so we've got this right here. So it's going to go ahead and create the sum function, put it into the sum variable, create this charges, and then it's going to call that sum function. We're going to step through it. So run with my Python debugger. Here it starts up. All right. So you need to pay attention to our call stack to see what's going on and the variables that we've got going. So I'm going to step into this sum by clicking this step into, and now I'm inside sum. And here I am in the first layer of sum, okay, the first entry in the call stack. And the variable that it's got right now is the parameter, that list that's coming in, 10.12 and 22.17. Is the length of the list equal to 0? The answer is no. So I'll step over that. And now I'm at this one, and it's going to create two new variables right here. Though, let's take a look. Head is just the first value in that list because it's list 0. And then tail is the slice from the second element all the way to the end. So it's another list. So now I'm saying I'm going to add 10.12. I'm going to take whatever's at the beginning of that list, and I'm going to add it to whatever the sum is of the rest of the list. So this is a different way of thinking about addition. Instead of being like, I'm going to take a number and then add another number, and I've got that, and then I'm going to add another number, and I've got that total, and then I'm going to add another number, and I've got that total. Instead, what it's saying is I'm going to take the first element, this first thing, 10.12, and then I'm going to go add up the rest of the list and then add it to 10.12. That's what this is doing. So right now I'm going to step into this, and now you can see I'm inside the top. I've added another entry to the call stack. I'm inside another copy of sum. Back down here, this is where we have a head and a tail. This one doesn't have one yet because it just got created. It's just hanging out. It's just brand new here. So is the length of the list 0? No. So we create a head and tail in this area. And so now head is 22.17 and tail is the empty list because there's nothing else left in there. So now inside this one, right now inside this copy, this call stack entry right here, right now head is 2217, its tail is 0. It's got nothing. It's an empty list. So we're going to step into sum again. And now you can see we have yet another version here in our call stack. So our for loop, okay, our for loop originally, like the value that we would be getting out, the for num in nums. In this case, our head variable is that num. In the first loop, the first call, we got the first value, 10.12. In the second one, it's 22.17. In the third one, we don't have anything in our list, and our list is equal to 0. The length of the list is equal to 0. So we're going to return 0 now. Okay, so we're going to return 0 from this version of the sum function, this copy of it, up here on the third entry, the third sum entry of the stack. We're going to return this 0, and it's going to pop back down to here because it's waiting for a value right now. This sum tail is waiting for a value. So when we do it, now we're back here. Now we only have 2 versions on our stack, 2 entries here on sum. And here's our return value, sum equals 0. So this value right here, this special variable is now this return value. So this is now 0, and our head is 2217. So it's going to add those two together and return it. And then that's going to get returned to the previous version of sum. We just keep adding every time we want to do something. We build up the stack until we get to somewhere that's we want to be, and then we return values and we work our way back down the stack. So I'm going to hit the next button, and it's going to stay on the same line here. But now you can see the sum 2217, this return value, that's this right here. So it's 2217, which originally was 22.17 plus 0. And our head is 10.2 plus that. So we're going to add up these two values, and that's going to be the value that's returned down here to the module level. That's the value that's going to be returned to Bill here. So let's go ahead and run that once more. Boop. And now we're back down here, and you can see that the return value, the sum, is 32.29, which was the total of these two plus 0. Because on that third call to sum, right? On the first call, 10.12 was our head. That was the head value. On the second call, remember, each entry in the stack has its own copy of its own variables. On the second call, 22.17 was the head value. And then we got to the third call, the list was empty, and we returned 0. And so it was 0 plus the head, which was 22.17, and that gets put together as 22.17, then it becomes the return value. And so it was 10.12, this head here, plus this return value, which is 32.29. And so that's how recursion for a for loop would work if we were turning a for loop into a recursive function. So again, here's the recipe. Don't worry about like learning it for real. I don't think that there's any recursion questions on the quiz or anything. So, you can like relax about that. So we have this, we figure out what the looping condition is, what that for loop is. So here's the list, and here's the element that we're interested in for each value, each time we go through the list. Then we make the function accept that list, and we split the list. So instead of lm, we end up having a head value for that entry on our stack. And the tail is the rest of the list after it. And then we end up doing something with that head, and then, doing some kind of combination, and then calling the same function with the tail until the tail is empty. Once the tail is empty, then we don't do anything. That's our terminal condition. Remember that terminal condition, or our starting condition. That's where we end up like returning 0 if we're adding things, or return 1 if we're multiplying things. So let's talk about the danger of recursion. We can end up with something called the stack overflow error. And what that is, remember, every time you call a function, you add a new entry onto the stack. The stack has a limited amount of memory allocated. I mean, it's a big amount of memory, but if you just keep filling it up more and more, and your recursive calls just keep going and going and going, eventually you're going to hit the top of that memory, and then it runs out of memory. And that's called a stack overflow error. If you go to stackoverflow.com, it's named after this right here, the stack overflow error. And so let's take a look at this right here. When we call recursion, the first thing it does is it calls recursion, which loops back to here. And so what does it do? Well, it adds a new stack to the list, and it's like, oh, I'm going to call recursion again. This is like an infinite loop, but with recursion. We can do this really quick in our code editor and see how it dies. So here's our code. All it's going to do is like infinitely loop. And what I'm going to do is I'm going to go ahead and put a breakpoint in here so we can watch the call stack grow. I'm going to go ahead and hit Python debugger, and we're going to start stepping into this. So here I am at the very first call of recursion. I'm in the module thing. So I'm going to step into that, and now I'm inside the recursion. But here's the recursion. It's going to call recursion again. And so now I have another entry in the stack. This hasn't moved anywhere because what's happening, this here says, I'm going to transfer control to the first line of the recursion function, which is the same line. And so this is how it's looping over and over and over again. So every time I click this, you can see it's adding more and more recursion calls here. Look at all. And if I keep going, recursion, it's never returning. It's always calling itself over and over and over again before it can return. Remember, it does this function call here before it does the return. Already I'm like, what? I'm right there. So if I go ahead and hit play, boom, right there. Maximum recursion depth exceeded, recursion error. And if we look at this, it goes on for a long time. I mean, recursion goes, the maximum recursion depth, I think, is 1,000 in Python. And the module call itself already counts as one. So I think that you can only get like 997 of them. So let's test it out. I'm going to go ahead and pass 1 in here like that. Instead of LST, we'll call that n because it's a number I'm passing in. What we'll do is we'll print n, okay? And then we'll call recursion again with n plus 1. So what we're doing here, we'll start off with 1, it will print 1, and then it will call recursion with 1 plus 1. So it'll be recursion 2, and it'll print 2. And then it'll call recursion 2 plus 1, which is 3. So it'll be recursion 3 and print n plus 3. So we can actually like track and see how deep we can go. So here we go. I'm going to run the Python file. Boom, right there. Look at that. Maximum recursion depth exceeded. Line repeated 996 more times. You can see right here, we got all the way from number 1 up to 999. And on that 1,000th call, Python died. Python's maximum call stack depth is 1,000. So if you have a recursive call, if let's say you were doing a for loop with a list and you have a recursive call that has a list that has more than 1,000 items in it, you will get a stack overflow error. We can test that out too. Let's do that. So what I'm going to do is I'm going to go ahead and do that. I'm going to build a list that's 1,000 zeros, for example. There's 1,000 zeros, and I'm going to pass that list in. And I'll do that same thing. Head tail is equal to list 0, list everything else, and I'll pass tail into here, okay? And then we'll check. If the length of list is equal to 0, then just return hi, like that, okay? So all this is doing, I've set it up. It's not really doing anything other than testing how many times we can call recursion. We have a 1,000 item list, and we're taking one off every single time. And when we get to a list of 0, we return high. So eventually this should return high if we don't exceed our stack allocation. So I'm going to go ahead and print that out. Here I am running it, and you can see, boom, I got my maximum recursion depth. What happens if I make this 999 long? Let's try running that. Nope, that one still dies. Let's try 998. And look at that, print high. So if we're using recursion to process a list, it can only be 998 items long. Otherwise, we get a Stack Overflow error, and there's no way to recover from that. So, recursion in Python for for loops, meh, probably not something you want to do if you can actually just write the for loop for it, which you can, because every recursive function can be a loop. So in summary, recursion is just a function calling itself. That's pretty important. That's all recursion is. Every loop can be written as a recursive function if you want to, and then too many recursive calls will cause a Stack Overflow error. That's what we learned about recursion.